Welcome. So now let's graph this one. We have y equals 2 cosine 2x minus pi halves minus 1. The first thing we need to do is factor out b. So b is the coefficient on x. So b is 2, right there. All right, so we're just going to divide both 2x and pi halves by 2. And I'll write it up here, I think. So here's step 1. Y, and include this in your notes, y equals 2 cosine. So I'm going to pull the 2 out. 2x divided by 2 is x. All right, what about pi halves divided by 2? I'm just going to do this over here just so you can see. All right, so if I have pi halves divided by 2, that's the same as pi halves times 1/2. Right, so if you divide something in 2, it's the same as multiplying by a half. So that's going to be pi fourths. Oops. And then minus 1. I have a recording box, and it's apparently blocking my 1. There we go. All right, so now we factored out b. We need to identify the amplitude. All right, so thanks for answering that question for me. All right, so the amplitude is the coefficient on cosine. The amplitude is 2. So we've done step 1. All right, now that we've identified the amplitude, let's identify the period. All right, so thank you for identifying that. And period is 2 pi divided by b. b is 2, so that's going to be pi. Pi is the period for this graph. All right, so now let's answer the next question, which is the phase shift. So what is the phase shift? All right, so let's go over the phase shift. The phase shift is what's added or subtracted to x when we have b factored out. All right, so we see a minus. Remember, minus goes with the equation. So that would be, I'm just going to, pi fourths to the right. Actually, I'll put right first. Right pi fourths. And now identify the vertical shift. All right, so let's go over that. So the vertical shift is what's added to the whole function. All right, that would be, and it's negative, so that means it is down 1. I guess I'll go this way. Down 1. And the midline would be y equals negative 1. So now we've identified all the features of our graph. Now let's fill in our table. All right, so I forgot to mention that. So you should have your table filled in, have your table created. A 6x6 table is what you'll need for this one. In the columns, we put x, we put period, then phase, y, amplitude, and then vertical. And so these are all placed so that they obey order of operations, right? Because amplitude, that's multiplication. That comes before addition, subtraction, right? PEMDAS. Period, this is not exactly multiplication, but it is a sort of a multiplication. We're affecting our x values, and we're changing them. And so we need to do that first before we add the phase shift. All right, so we have identified our 5 key points. Let's use the period divided by 4 to, oh, before we do that, sorry, we did not identify our 5 key points. All we did was label the graph. Now let's identify our table. Now let's identify our 5 key points. Always 0, pi halves, pi, 3 pi halves, and 2 pi. This is cosine. Cosine starts at its maximum. So 1, 0, negative 1, 0, 1. And just as a reminder, since this is our last cosine graph, our last sine or cosine graph. So this is the point 1, 0. That's where that value comes from. This is 0 degrees. This would be pi halves, 0 radians. This would be pi halves, and this is the point 0, 1. And cosine uses 0. This is pi, and this is the point -1, 0, and cosine uses the x value, so that would be -1. This is 3 pi halves, and this is the point 0, -1, and cosine uses the x, and then 2 pi is coterminal to 0. We're in the same location, so again, cosine uses the 1. All right, so now that we've identified the 5 key points, let's use the period divided by 4 to find the new x values. So the period is pi, so of course pi divided by 4 is pi divided by 4. We start at 0, always, and then we're just going to count by pi fourths. So 1 pi fourth, 2 pi fourths, and we could write that as pi halves, 3 pi fourths, and 4 pi fourths, which we could write as pi. And notice that our last value matches the period, and that always has to be the case. Now that we've adjusted with the period, now we need, oh sorry, put that in the wrong spot. Now that we've adjusted our x values using the period, now we need to add the phase shift to our values. All right, so the phase shift is pi fourths, so we're going to add pi fourths to each of these. Ooh, that's pretty glitchy there. That was saying plus. There's no way that can be a plus, can it? We will put plus pi fourths over here, and we will drag it in. The glitch is getting bigger, I think. Oh, no, I don't want that. The only problem is if I drag it in, I get stuck with that. No. There. In between. All right, because I don't. If it gets trapped, if that blue box lights up, it gets trapped there, and then I can't get it out. So that would be pi fourths, and then pi fourths plus pi fourths. That's 2 pi fourths, and 2 pi fourths is pi halves. Pi halves is the same as 2 pi fourths, right? We have it written right over here. So 2 pi fourths plus pi fourths. Ugh, that says pi fourths. And it wasn't so glitchy yesterday. I did the same thing yesterday. Let's try to get it in the middle there so we don't set off either box. Oops. There. So pi fourths, 2 pi fourths plus pi fourths is 3 pi fourths. 3 pi fourths plus pi fourths is 4 pi fourths, or pi, and pi plus pi fourths. All right, so pi is the same as 4 pi fourths. 4 pi fourths plus pi fourths is 5 pi fourths. So there we have it. We have all of our values for the phase shift. Now we're going to multiply. We're done with the x values. So this is our x for graphing, is right here. There's our x values. Now we need our y values. So we have the starting y values. We need to multiply those by the amplitude. So we're going to multiply all of those by 2. So that would be 2, 0, -2, 0, 2. And then we're going to add in the vertical shift. Right? So the vertical shift is down 1. So we're going to subtract 1 from all those values. So -1, -1, -1, -1, -1. All right, so we have 1, -1, -3, -1, and 1. And there we go. All right, so now let's graph the midline. Actually, first let's label. I always forget that. Oh, let's label the values on the graph. Then we'll graph the midline. All right, so we need fourths. this isn't a very big graph. Why don't we make each line worth a fourth? All right, now I don't want to write in, every single line. I'm going to write in every other. So if one line is 1/4, 2 lines is 2/4, which is the same as pi halves. So that'll be pi halves. This will be 2 pi halves, or pi. This will be 3 pi halves, and so forth. And then this would be 2 pi. All right, and so that should be fine, because it's not that big. It's a little bigger than pi. That's it. We have plenty of space. All right, and this can go up by 1. That'd be fine. The last graph, I should have made it go up by 2's, and I wouldn't have gone off the graph. I don't know why I didn't do that. But this one, I don't need to. All right, so we're going to graph the points. So we have the point. So we have our x, that's a phase, and y is the values for the vertical. So that would be the point pi/4 1. All right, so we'll graph that point. Oh, let's also graph our midline. One last thing. So the midline is at -1. And that is what our graph is oscillating about. Now we will graph our graph. So let's graph the point pi/4 1. So that's right there. And then we have the point pi halves -1. So that would have been an x-intercept, but because our graph's been shifted down 1, it's that point's shifted down 1. All right, but notice it is on our midline. All right, so now we have the point 3 pi/4 -3. And so that's going to be right here. And then we have the point pi -1. And then finally the point 5 pi/4 1. Oops, that thing is supposed to say be a pi. 5 pi/4 1. That's not very neat. I can just barely see it, but it's not very neat. Maybe I can make that a little neater. Oops, there goes my purple. Here, I'll just write it like that. Good enough. All right, so 5 pi/4. All right, so that's just one more fourth than 4 pi/4, and that was +1. All right, so now we'll connect. Don't make it look like his hands are up in the air, like it just doesn't care. All right, because it's not going to keep increasing. This is its maximum. It is never reaching beyond that point. So you want to make it look as though it's sort of turning there, so you don't give people the impression that this is a parabola. All right, I don't have that issue with sine so much, but this one, cosine, just because it's the section of graph that's used for one period, just tends to look a little like a parabola. So there we go. There's our graph. All right, we've graphed our points. All right, so now you shall be experts in graphing sine and cosine. You know all of the steps. You've been practicing filling out your table and graphing. The last thing we need to do is the domain and range. By the way, this might be a formative question, to know the domain and range. And I'll cry if you miss the domain. Right? For both sine and cosine, all real numbers, nothing will change that, because this is just a piece of the graph. Right? We could make 1,000,000 clones of this on either side, and then we would still not have the whole graph, because it goes on for infinity. And then the range, the low value is -3 and the high value is 1, and that's it. Thank you for watching. All right, so we will look a little bit at tangent, but we will not really spend a whole lot of time graphing tangent, just finding some key characteristics of the graph of tangent. All right, so thanks for watching, and bye for now.